This is Mech 330, Programming for Industry 4.0. We start by opening the converto.py file, and we're prompted with what type of conversion we would like to make. We're going to start with temperature. Now that we've put in temperature, we're prompted what direction would you like to convert, USAN or European? We'll start with USAN. And then we're going to convert between the two. So we're inputting a Celsius value right now, and it's going to end up as a Fahrenheit value. So 21, that changes into 69.8 Fahrenheit. We can do this again in European. And that brings it back to 21 Celsius, reversing it. Now we're going to try distance. This is inches and millimeters. We're going to start with USAN. This will convert from millimeters to inches. So we're going to try something like 300. And that would be 11.81 inches. We're going to try distance again and try European. And we're going to say 5. And that's 127 millimeters. Now we're going to try time. USAN is military time, European standard. So we're going to switch from standard to European first. Military time to European. So 1400. And that's 2 p.m. And then we're going to try the opposite. USAN. 2 p.m. And this will work for any times or temperatures. I can also show you one way that we're guarded from breaking. It shows that time must be entered in the form hour, minute, AM, or hour, minute, PM for USAN. And this is also operational for the direction. We'll try that as well. And then we could still say, and it shows that the direction was typed in correctly. So now we're going to look at that converto file. And we see that we're importing serial, which is another file. And then we're going to make a main function here, which we're asking for the user's input for temperature, distance, or time. And then we're making a variable that's asking for the user's input for USAN/European. And then we're making a variable asking for the user's input of the value that they would like to convert. And then we're making a variable called convert that's creating an imperial object, as we can see. And we're passing through convert type, direction, and value from that class. Then we're saying that if the user's input is temperature, we're going to continue into the if statement, of course. And if the direction is equal to USAN, a string called USAN, then we're going to print that this is your new temperature in Fahrenheit using the value from the other function. And then we're doing an elif here. And the direction equals European. We're going to print this in Celsius. And then we're doing an else that these directions must be USAN or European. We do something very similar for distance. If direction is equal to USAN, we're printing it in inches. European is millimeters. And else, direction must be either or of these. And then we're doing an elif for time. If the user's input is time, then we're going to continue into the if statement. And then we're calling the time conversion function and storing the result in success here. So we're taking the result that we get, kind of like the other ones, and we're storing it in success in time output. And if success from the convert time was successful, then we're going to print this as our new time. And otherwise, if it wasn't successful, we're going to print this conversion type must be a temperature, distance, or time. So this is basically checking if they're putting in the correct values and if it's an actual time. And then we're going to call the main function, which is here. So then we're going to look at the actual code. For the serial.py file that we import to our main function, we start by making a class called imperial. We then initialize our attributes to describe the conversion type, direction, and user value. Then we store these attributes in the variables of our class. As we can see, convert type, direction, value. So then we create a function that calculates Celsius to Fahrenheit and vice versa. As we can see, we start by making the user input or the self value, which is the value that the user puts in. We turn that into a float just to correct. And then if the self direction that they placed in prior is USAN, this determines the way that we're going to convert it. In this case, it's going to make it Fahrenheit from this formula. And then on the other side of that, we do a elif for European. And then this formula will switch it to Celsius. And then we also do an else in case that either of the directions weren't correct, just to prompt the user as prior that direction must be USAN or European. And then if that's not performed correctly, we return. And then if it was performed correctly, we return self.value. For distance, we do something very similar. We first turn it into a float. And if the direction is USAN, we then take the value and divide it by 25.4. And that should take it and turn it into inches. On the other side, European, if we multiply it by 25.4, that should turn it into millimeters. So the user could use either. And otherwise, if the direction was neither prior, then it's going to return this print statement. And it's going to return back outside of the function. And then as well, if they did it correctly, then it will return outside of the function with the self value. For time, I make a function that calculates standard time to military time and vice versa. I start by taking a string variable and storing the self.value or the user input into this variable. And then if the self.direction or the user direction equals USAN, I'm then going to check whether am is found in the string called string. And if it is found, I'm then going to store it in the variable am/pm here. If PM is found, then I'm going to store it also in AM/PM. So that's just checking if the user placed AM or PM when we're converting to military time. And then on our else, this is if they didn't use that, it's going to print the format that they should use. And then it's going to return false, meaning it was unsuccessful, and then return the self value. So this is an early, early return for a bad input. So I then make a list called time, AM/PM split, and I'm going to use the split method on the string that we made earlier. And this split method is then going to split by the first index of AM/PM, which that would be the A or the P. And then it's going to consume the A or the P, so we're left with the 2:00 in the M. And then we're going to do hour minute split as another list. And we're going to do the split method again on the colon. And this is going to split the 2 from the 00 or the minutes. And then we're going to take the hour and we're going to turn it into a integer and add 12. And then we're going to store that into our int. And then we're going to take a string and put in our int and then a colon and then the minutes that were not changed in the same provided by the user. And then we're going to assign that or store it into self value. And then this would end up being a true self value. For European, we're going to do something very similar. We're going to make a list called our min split and split it by the colon. And then we're going to have our hour, which is going to be our first index of our min split, and then minute, which is the second or number 1 index of our min split. And then we're going to take our hour and we're going to turn it into an integer. And we're going to make that a variable called our int. And then we're going to say that if our int is greater than 12, then we're going to minus 12 from it. And then we're going to add PM. And then otherwise, we're just going to keep it as AM. And then we're going to put this in a string called our int colon minute AM/PM. So this is going to be able to convert it back to standard time. This is going to convert it back to military time. And then from there, we're going to do an else. And this is going to also be the direction. So if they determine the wrong direction, or they input the wrong direction, then it's going to make this print statement as the else. And then it's going to return a false. And then it's going to return our self value. So this is once again a return for a bad input. And this is the return for the good input. And this is going to only work if the main function determines that it was a true value. So that's the code for this week. Thank you for watching.